Hello and welcome everyone. Thank you for joining us today for the Strategies for FinOps Encouraging Engineer Trust webinar. My name is Daniela and I'll be the moderator for today's session. I'm excited to introduce Chuck Tatum and Andy Walton at Densify. Hello, hello. They will lead the session today and take us through how to supercharge FinOps by empowering engineers to be part of the solution along with a live demonstration. And with that, I'm going to pass the mic over to Chuck to get us started.
Thanks, Daniela. Hey, Andy.
Hey, Chuck.
This is a very important sounding title with some big words, but we're going to keep it pretty straightforward. Our abstract talked about strategies for FinOps and the notion of convincing engineers to take action. And it's a little bit hard on engineers in that engineers generally aren't asked to focus a lot on cost. They're focused on having things perform well and deliver good value for the business. We're going to talk about how we, as part of a FinOps strategy, can do these things like encouraging more trust in the requests that we make of engineers and overcoming some of the resistance that we see. But I think the third point is most important, and that is we'll talk about some things that make it easier for engineers to just participate in the overall optimization process, and some innovative things we're doing with our technology that make it easier on engineers. So let's dive right in and just talk about some of the trends we see in our customers and in the world of FinOps. We love the surveys that the FinOps Foundation does when they ask their membership, what are some of the top things they deal with in driving overall FinOps programs. We pick on the engineers because the number one is getting engineers to act, the number one challenge we hear about. And we'll come back to that because, again, we're not asking engineers generally to make it a priority. So how do you find that balance? But if you look further down in those top 5 items, the notion of adoption of driving FinOps adoption, and then the fourth one I really like, which is governance and policy at scale. Because if you can do that intelligently, perhaps using software and analytics, you have an opportunity to just encourage better choices in general, which should reduce the amount of hassle that you have to put on people to drive optimization. And we'll come back to that. Invariably, in our customer base, we start off in engaging by hearing very similar things. And that is no shortage of recommendations for things that can be done to improve the cloud bill or improve efficiency. But there's this impediment of how you actually get it done. Because when you dive into who owns what, the domain of finance, the domain of paying a better price, getting the right discounts, versus the actual optimization of infrastructure, who controls the actual resource, is quite different than, in many cases, who are driving overall FinOps programs or a focus on financial matters as it relates to the use of cloud. And so this is really where we find this division of responsibility and this importance of trust, because cloud cost optimization is often starting with an understanding of the bill, understanding the spend, budgeting and forecasting and making the right commitments in order to get the best price possible. And only when you turn to the engineering world, the architecture, the platform owners, and the notion of the actual resource consumption and asking for change to be made here from an optimization point of view, meaning if we think we could do better from an efficiency point of view, or the cloud catalog, the provider's catalog has evolved over the last little while, maybe there are some better choices for us for our workloads that might drive more efficiency and price advantage or cost advantage. It really is the domain of the engineer and the app owner, and it's that division where finance-oriented tooling although they might make suggestions. Even the native cloud stuff in the FinOps area will make suggestions on maybe where there's some slack or some excess resource that shouldn't be paid for. It's where we see that resistance and trust from an engineering perspective, because if an engineer doesn't trust a recommendation, it's very easy for them to ignore and or move on to their prime directive, which is just making sure stuff is running and up and supporting the business. In our experience, the critical ingredients around empowering engineers starts with the recommendations that are given to an engineer, the asks that are made include all of the rigor that they can actually say, okay, there's all of the ingredients in that analysis that mean that the recommendation is sound and I could actually take it, and that I see the proof why each recommendation that I'm asked is well-founded, it's safe, and actually actionable. But we see, more importantly, the next two items, which is integration to change management processes, and something we're going to show you around guardrails. The number 3 and 4 are about making it easy for that trusted or agreed upon recommendation to actually be applied back to the infrastructure. Or in the case of guardrails, just tell an engineer what a subset of optimal choices might be so that over time they make better choices versus being chased all the time. So these critical ingredients are where we've focused from a technology perspective, and we will take you through now a few more slides and some demonstration about how Densify is really about precisely and allowing the continuous optimization of the resource from a performance and cost perspective. And I'm going to hand over to Andy to take you through that.
What I'm going to do is just take a few more slides just to explain how our technology actually works, and then we'll get into a quick live demo of called the catalog map and describing this whole concept called guardrails, really, and how we use those to help make the engineer's choice. Lots of variety there, but specific to things that are within the boundaries of the technical and cost optimization. So in terms of selecting the right infrastructure, we'll use a simple example of, say, an Azure instance. And how do you upgrade this thing? If you're using a standard DS4 V2 as an 8x28 today, what are your options to go forward? DS4, that's too old. You don't want to go backwards. A DS4 V3, that sounds like that would be the next one in the run, but it doesn't exist actually. The naming convention for Microsoft in the cloud is a little bit obscure. So how about a D4S V3? That's the next one in the series. Well, it's not large enough. A D8S V3, yeah, that one would work. Okay, so we could go to that one as the next option. How about the next more powerful one, a V4? Well, that wouldn't work. There's no local disk. And so on and so on. You can see that there's additional choices that are not necessarily obvious from the number that you have to pick from. A DS V4 and a V5 would actually work. A D8 DS V5. But one of them, a maximum of 16 data disks and 4 network adapters. So you can't pick that one. And that's not even considering at this point, if you're trying to do this by hand, well, what about different families, burstables or memory optimized or compute optimized? The reality is that there's hundreds of choices, and this number 2022, 625, it's likely even higher, probably over 800 at this point. But as that catalog grows year over year, your options to choose are getting larger and larger, and you have to do this programmatically as opposed to manually.
We often say there's probably the perfect instance for every one of your workloads. It's just an impossibility that you will find the perfect one in a manual way, right?
Exactly. And I'm going to show you, we do come up with that perfect choice. But now there's some boundaries with the whole catalog map and the guardrails to enable a little bit of option in that choice. Let's dig into that. But first off, how do we come up with that optimal choice? Again, our software, what it does, agentlessly goes out there and scours through raw utilization data, whatever the history is, 60 days, 91 days worth of history. And then it uses machine learning on that history. As an example, it will look at individual hours. So it will pick, say, 12 o'clock midnight every single day of that history that we have. And then it analyzes it and builds a predictive hour. with a minimum, average, sustained activity, maximum using these candlesticks. And it does that for every hour of every day and builds out what we think based on history is that predicted day in the future. And that could be based on a very conservative, give me the busiest hour of every day and build a perfect storm day. We come up with a predicted view that considers the peak utilization, sustained activity, average utilization, and then we model that for every single metric that we capture, whether it be memory, disk, network, IO, IOPS, packets, what have you. We consider storage details, network capacity, what's running from a software perspective, what's available in different regions. And this new concept we have called this provider catalog map, where we take every single option that's available within that region and consider all the different families and capabilities that those instances have, look at what's available from a sizing perspective in terms of number of CPUs, and then consider the policy, not just limits as to how busy something can get, the disks, the hypervisor generation, the specific type of storage or chipset capabilities, and how much history do you want to take into effect. And then the analytics churn through that and come up with, in this case, the catalog map. And I'm going to actually get into this in the software, so I'm not going to explain too much about that right now, but the idea being that it's going to come up with your best choice. It's going to come up with some options. It's going to disqualify some things because they don't exist in the region, or they don't have the technical capabilities, or they're too small. They won't actually run the workload. So I'll get into that actually with the software in just a moment. The concept of the guardrails, when we come up with a perfect answer, which can be automated, if we're going from A to B, there should be a perfect answer for that. The catalog map allows us to visually identify the things that are too small in red, the things that are incompatible from a hypervisor version or storage or NICs, what have you, and your viable choices will show up as a larger set of options. And then we'll start narrowing those things down based on, well, you can't pick everything. You can't have something that's 5 times or 10 times more expensive than what you're currently using. So your set of viable choices will be available based on the analytics, and we'll identify those things. That optimal instance sits right down there. And then as we start twisting the dials in the software, creating these guardrails based on your technical, your workload, and your cost policies, that specific region based on the spend tolerance is going to get smaller and smaller. So depending on what sort of program you're running and how much options you want to give to the development or the engineering folks, then that set of optimal instances will get down to a place where the only acceptable answer will be the optimal selection. But again, let me show you how that actually works.
Key concept here is that instead of telling people exactly what they must do in order to be perfect, we are starting to constrain, using those guardrails, choices that are just not responsible. And of course, the dividing line between responsible and irresponsible, if you take all the technical constraints out of them, you're not going to make an irresponsible technical choice, but let's say your stuff will run, but at what cost is acceptable? And a lot of choices get made that are just outlandishly more than what is actually required for the workload. If you restrict the choices, then over time you make better and better choices.
So let's visually show how that actually would work. And we've done variations of this demo over the years, different areas of the software. So I'm not going to give a full-blown demo again. I'm sure you're happy to hear that. I'm going to just drill into the area where the catalog map is. So from the main overview screen that shows all the things that we're analyzing today, I'll click on specifically EC2, Infrastructure as a Service for AWS. And I'll narrow it down just to show what we're doing here. We're showing all the different applications here. Essentially, we're grouping by application. We could be grouping by any number of things. I could say, well, let's just focus in on a couple specific applications, mobile dev, mobile prod, hit apply. And now I've got a subset of the things I actually want to dig into. And I can simply click on the 12 here and say, okay, show me the recommendations for these instances. And you'll see the key component here is that you're currently running on a C4 extra large. And this particular instance, the recommendation is to go to an M7i Flex large. And the new component that we've actually introduced is this area called the catalog map. So when I click on that, it will actually show me visually that same thing I showed you in the PowerPoint, which essentially is across the bottom, you've got the instance types that are available. Now you can show those things as every single one that you've got. The commonly used ones in your own catalog are available in the region. So that's what I'm using right now is the key ones and the ones available in this database as well as in the region itself. And on the vertical axis here, you'll see just the sizes of those instances. Anywhere where it's white, the instance doesn't exist or not available in that region. Red means it's insufficient resources. Orange across the area here means technically incompatible. And as you start getting into yellow and green, essentially now green are the options that you have. Here's where we are today, a C4 extra large. Here is our optimal area, which is the M7i Flex, meets all the policies, running on the latest Sapphire Rapids chipset from Intel, got certain capabilities, certain sizes, etc. And so what we can do in order to twist the dials here, and you can use the filters again to highlight certain features of the chipsets and other filters we could introduce here over time. But if we twist the dial, so to speak, and say, what's our spend tolerance? Right now, it's 5 times more than optimal, which is why you see so much green in here. So we're giving a fair bit of leeway in terms of what the choice could be. If I change that to say, okay, I'll allow the engineer to spend double what they're spending today. Now you can see that we have a number of choices that are still viable, the green ones, but the ones that were previously green have now gone into the yellow because, okay, they cost too much. It's just too expensive. And the more we twist that dial and dial down the amount of spend tolerance that we have, the more we are actually getting to a point where, you know, there are less and less choices till such time as, and I won't do every single one of them here, but say 5% more than optimal, and you've got 3 choices, and then you can get all the way to optimal. So we used to say that it's impossible to automate multiple choice because you want to have your best optimal answer and be able to automate it. And we've actually come up with a way that it could be done where we can take this, Chuck's going to speak about this in just a moment, where we can dig in and actually show you a programmatic way to take this choice and make sure that the engineers still have the ability to have some leeway, but are still coming up with the things that are technically compatible, available in the region, and within the spend tolerance that FinOps will want to see.
So if we zero in on optimal choices or an optimal choice, there really are 2 ways to act on that. One is to directly take a recommended action, for instance, through ticketing or making a manual change or even integrating with things like Terraform and as code frameworks. What's new here is just the notion of preventing bad choices via guardrails and embedding into policy engines and actually telling an engineer or a requester at deploy time whether there's something better for their workload or whether they're actually falling outside of the corporate guidelines. So if you were to think about executing a recommendation where you've got a deploy path and a cloud environment where Densify is watching over the environment, it's making a recommendation through our ITSM module and integration. You're maybe pushing through to your ticketing system, which seeks an approval from an app team. They get, we didn't show it in the demo, but what we call an app owner report, which is all the proof behind a recommendation. It's very popular with customers. It's basically a PDF payload that goes along with the request that shows the policies that fired, the before and after, the predicted behavior of the workload, all of that stuff. We show our work. And then in this case, we might pass it back to a Terraform module, which based on that approval gets applied back to the infrastructure. So this has been historically a very common way for our customers, once they agree that our answers are trustworthy, that they actually start to push it through change control to get it applied. Now, if we jump to the notion of the policy-based guardrails and a similar, let's say, chain of action, it looks a little different in that in this case, we're using a HashiCase with Sentinel, which is their policy framework, where that guardrail gets implemented into Sentinel. A deployment is being requested, and based on those guardrails, we are giving a variety of warnings And of course, the level of enforcement could be just a warning, but it could actually be blocking someone from doing something. In this case, hey, you need a local disk. There's no local disk in that instance, or there's not enough memory available in that instance that you've requested. Or as Andy showed, you're outside the spend tolerance for our policy, and what you've asked for is considered to be too expensive. And then, of course, there are equivalents in things like Azure policy or things like Cloud Custodian or AWS config, depending on what's in your DevOps chain and the way you apply policy. So there are options here and customizability, but the point is that instead of chasing people around a specific choice, we are simply intercepting and evaluating against guardrails to tell that engineer or developer very important information with respect to how they're doing against that policy. So this is really about an integrated paradigm for resource control. I like to compare it to security products. Nobody these days rebels against the fact that as part of your deploy process, you've got things that will prevent people from doing things that are offside from a security policy or vulnerability point of view. What we're talking about here is, in a similar fashion, preventing engineers from doing things they should not do versus trying to fix it after, which is really, really difficult to do. So thinking about it in the context of security policy and security compliance, this is the equivalent for resource in the cloud. Based on, we didn't go into too much detail, but it's based on that deep technical analysis. And in fact, you can engage engineers and technical staff in figuring out what the policies should be so that when it actually spits out a warning, everyone understands why that warning happened.
Sure. Relevant discussion right now. They just talks about whether an engineer would take a right sizing choice. If they assume they do that, but they choose a non-optimal choice because of other constraints they already knows about, or they only know, an application constraint or company policy. Is a tool capable of learning from this choice and improving its future recommendations? The answer is it's where we're going. Policy today must be changed and altered by authorized individuals, folks that is authorized to make those changes, because a single engineer out there isn't able to change our policy today because perhaps it's not something that is corporate policy, as an example. But as we move forward with AI, this is an example where policies could learn over time from that kind of choice. So great thing is policy controls what they can do today, and it can be quickly manipulated by individuals, and it's a good area for learning as we move forward with AI.
It also allows you an approach that says, in phase one, we're just going to warn people or tell people and educate them, not stop them from actually overriding or making a choice to suit themselves. What we often find during implementation and solutioning is that engineering teams will be part of configuring those or originating policies such that the types of sensitivities they might need represented for a particular application are reflected in those policies. We don't expect that out of the gate anyone is making these policies hard and fast rules and stopping people from making other choices. It's about gradually over time enabling better choices. Options for engaging with Densify and procuring Densify. We have a wonderful partnership with Intel where they brand Densify as Intel Cloud Optimizer, and really based on their interest in just helping customers make better choices within the Intel product families that are embedded in huge quantity in the cloud, they will actually sponsor a full year of Densify usage for qualifying organizations. So I mentioned that. There's a QR code where you can submit a request to find out whether your organization would qualify. I did want to point out our analytics and what we do are really leading in the market. There's a GigaOM report on cloud resource optimization. There's a new report, literally came out last week, around containers and Kubernetes, which calls out a similar leadership position for Densify and our technology. If you're interested in that, I encourage you to go and read those reports. A number of resources available, including our Densify Talks podcast, features our customers in various forms talking about these exact topics, how they manage FinOps and related engineer interaction inside their organizations. new stuff usually on a monthly basis there. And of course, the usual social channels, lots of our videos and demos up on YouTube. I see a question flashing there, Andy. Sometimes we are asked about whether we are agent-based or agentless. Andy, can you answer that with respect to how we instrument an environment?
Yeah, it's all agentless. We use the cloud providers API, things like CloudWatch in AWS, or for Kubernetes across any of the three major clouds, we do Prometheus. So no agents to drop down on any of the infrastructure. And we can import data from some of the major monitoring or observability tools like Datadog to further augment our answers. As an example, memory metrics are really helpful for the infrastructure as a service stuff.
We've used all of our time. Thanks for spending it with us, and have a great day.
Thanks. Take care.